Welcome back to the channel. So yeah, we'll be doing something very super exciting today. In the last one we reviewed just simple, router configuration, so router to router, switch to switch. So now we're going to literally be testing out how a network would look like totally, right? We're going to have our routers. And then when you have your router, next thing you want to have is your switches. And then with your switch, you want to have end devices like your laptops. Let me say laptop and a PC, right? And we're going to do our connections right away. So yeah, um, the crossover is always for router to router. Then straight through cables, it would always be for like devices. In this instance, router to switch. Yeah, same straight through. Classic connect one to the PCs. Let me just use the automatic. It makes it faster. Okay. Let me do this to this. And the automatic is connected. Let's just use the automatic connector. So yes, we're done with this. And this is really going to help us have like um maybe I just bring up more end devices here. Let me bring up more here, like a PC. So we're going to use this to kind of like have base understanding of really how a network works. We're going to do configurations. We're going to have to configure everything and test it out to work. So this way it also gets us prepared for, the next thing which we have to treat, which is the static routing protocol before moving to dynamic routing and see how far we can finish this beautiful course and program as soon as possible. Right? So yes, the next thing we want to do is more like identify our networks. So let's just say we're going to use say 10.20.30.1 here, dot one here, and 10.20.30.2, and on this area can be the okay, here could be the 10.20.40 network dot 0. Here would be the 10.20.50.0 network. So what we're going to do here is simply, we could just use serially. Maybe we could give this PC here 10.20.5, here 10.20.40 dot maybe 10. Maybe we could move in twos, or this one might be dot one, this one might be dot three, right? Or this one might be 2, 4, 6, 8. Let's just see how all of that goes. And remember, whenever we want to do our router configuration, let me just always put this on the side here. Is always enable configure terminal. Then you enter the interface XXX. You assign IP address, IP add XXX, no shorts, and exit. It's just that's really how our configuration would go, right? So I'll come into our first router, coming into the CLI, like we said. We have to say no. We also have to note the connection from here to here are on the 0/0 interface, while the interfaces underneath the routers are the 0/1 interfaces, right? So we want to enable conf t, which is the configure terminal. Once we got that, we are going to say we're getting into the the interface, say IP add 10.20.30.1, and the subnet max, I'm going to use /24 255.255.0, no shorts, and exit. We'll go into the next interface 001 IP address. We are saying 10.20.40.1 255.255.255.0, no shorts, and we're done with the configuration for router 1. We're moving right into router 2. Let's just bring this here up. Let's just bring this here. It's fine. So we're saying no, enable conft int gig 000 IP add 10.20.30.2. Oh, I forgot my subnet max 255.255.255.0. No shorts. X int gig 0/0/1 IP add 10.20.50.2. Should we give it .1? Let's give it .2. It's fine. 255.255.255.0. No shorts. And yeah, I think this is really how the how very simple the configuration goes, right? So this interface is .2, this interface is .2, this interface is .1, this interface is .1. So the next thing we want to do, like I said earlier, whenever you're, or I don't know if I said this prior, whenever you're making configurations on the simple network like this, you do not necessarily need to touch your switch, right? Because what your switch's primary goal is just to send packets from the router. It just receives packets from the router. It's like an access point, a means through which packets just pass through. And packets can pass from the router to the from the host to the router or network, and maybe go elsewhere wherever it wants to go to using the default gateway. So here is usually this interface here will be the default gateway. So now to add IP addresses on our PCs is pretty very simple. One step is to we can come to desktop here, or we can come to command prompt here, and we say ipconfig. Okay, ipconfig. We're going to say 10.20.40.3 255, then our default gateway 10.20.40.1. Okay, now let's come to this IP address. I just hope I'm correct. It's been a while, right? When we come to our config here, okay, you can see that simple command on our on our command prompt has really done that. So the 10.20.40.1 is the default gateway, and when we come to the interface, you see that we assigned the IP address, right? This is to assign the IP address. So that was the format for ipconfig. Whenever you type ipconfig, it is IP address, subnet max, and default gateway, right? So one of the reasons why default gateway, might be very important is when there are, multiple networks, or rather, you see two routers have different host devices. Two routers have different host devices. As you can see here, this is like different networks here, like this. Let's say what fill color do we give to it? Let's give a very light fill. Say so. Two routers has different devices, and you can see this here. So this is his zone. Had it been you have only one network like this, without setting default gateway, there might be no need for default gateway. It's going to work pretty fine. But the fact that you want to communicate with another here, like so, you need a default gateway. So it's going to tell you, and the default gateway is that interface facing the network here. So if we hover on this router, you can see our IP address. So the interface facing the gigabit 01 is the 40.1, right? And the 40.1 becomes our default gateway because it's through that point. That's the point connected to the hosts. And of course, their IP addressing are still on the same network. So it is through it, as long as it's still connected to the router, and the router has another interface of 20.30, which connects to another network of or another router on same network of .30. So it's able to send packets to this router, right? So yes, and another easier way, like a lot of people want to do, is just to come in. We're going to configure IP for this laptop now. Another way to do that is people will come to, click on the device, you come to the desktop, they just click on configuration and manually type out all of this stuff, right? IPv4, IPv4 address. So this one we could say is 10.20.40.5. 255.255.255.0. Then the default gateway 10.20.40.1. There's how some people would rather do it. Oh, so like as you can see, this here is on static. It's on static by default, and that's how you get to do your configuration. And the same thing for this PC here. Come to config. Come to config. We'll do our configuration. Our default gateway, of course, is the 10.20.50.2. Remember, you can see the 10.20.50.2. Then the IP addressing is going to be 10.20.50. Let's say I'll give this 4. So of course, because this is a class A network, it's really going to give you that class A subnet mask by default. But we will just have to update it ourselves. Yeah, we did set our. So we're going to go into, since this interface has .2, we're giving this .4, and the others will have that increment in 2s. Let's be sure we have our default gateway set. All right, we're going to be doing same for here. Just continue. IP config 10.20.50.4, no, rather 6. 255.255.255.0. Then our default gateway 10.20.50. 10.20.50.2, right? We'll come in here, make that verification. Okay, so I will just be working with the command prompts. IP config 10.20.50.8 255.255.255.0 10.20.50.2. Lastly, we're coming here. IP config 10.20.50.10 255.255.255.0 10.20.50.2. Okay, all right, this is set. So default gateway wasn't set here. Default gateway, one way or the other, they didn't get in here, which is very important. 10 dots 20.50.2. Let me verify this. Okay, our default gateway is here. Our default gateway is here. Okay. So now, well, this is literally how to do, simple packet configuration, a simple network configuration on your Cisco Packet Tracer. One way you'd want to get to test that is all working is, of course, the ping test, right? So I might come from my PC1. You come to desktop here and you come to your command prompt and you ping. Let's say we want to ping within the same network from the first PC of the 50.0 network. We want to ping the last. So the IP address is 10.20.50.10. You see, it was very successful. Now let us try to ping a network from one of these PCs here of the other network. Let's try that again. Dot 40.3. Destination host unreachable. You saw that. This is dot 3 and this is dot 5. Okay, we'll try that again. Bring in. The host is unreachable, right? But if we try to ping the router, it's really going to work actually. So if I say 30.1, let's see if it's going to work. 30.1 timed out, timed out. Interesting. It didn't actually get to work. Hmm. I'm going to try this one more time. Okay, so it's not working, right? So yes, this is how this simply and really does look like, right? And you see that you'd see that you can do all of these configurations, right? As long as it is within this network, say this network to this network, you can be able to ping this network to itself, you can be able to ping, right? It's going to work very nice. If you want to ping within this network to work, you want to ping between this network, it's going to work. But if you want to ping a device outside, they would not work. And that is really going to lead us to um something very exciting, which is the static routing, a protocol, the static routing protocol, which is going to enable us that, hey, from this network, we can ping to this network. Matter of fact, we might even add two more networks, right? And we're going to see how we'll be able to ping across those networks, through that protocol, right? So see you on the next one. Bye.